Chapter 11, Section 5 in the 7th grade note-taking guide is entitled Making Predictions. So let's go ahead and start off with the definition of what is properly a prediction. A prediction is something you can reasonably expect to happen in the future. Something you can reasonably expect to happen in the future. So what they're going to be doing in this section here is they're going to be giving us mathematical figures, facts based on the probabilities. And based on those probabilities, we're then going to take a situation and apply that probability to that situation to find out the chances of something or figure out how many times something happens or whatever we need to find out about that given event based on those mathematical figures and facts. So let's go ahead and take a look at the first question here. Number 1 says that Lawrence finds that his experimental probability of getting a hit is 40%. Out of 350 at-bats, how many times can he expect to get a hit? Okay, so there's a couple different ways we can go about solving this problem here, and that's what they're going to run us through here to start off with. In the first method here, they've decided to set up an equation to solve here. What we know is that he's making the hit 40% of, that's an operative word, 40% of the time. Well, we know that of implies multiplication. So if he's hitting it 40% of the time, and those number of times is 350 based on the question, we're going to multiply together 40% and 350, and that'll be how many times he would expect to get a hit. Now, as you can see, looking at what they've done here, they didn't actually use 40%. They used 40% as its fractional form, 4 out of 10. Of course, in the last few lessons, you spent a lot of time working back and forth with decimal fraction and percent, so changing 40% into 4 out of 10 is something you're already familiar with. We take 4 out of 10, which is 40%, and multiply it by 350, and that's how we come up with 140, as in if he goes up to bat 350 times, he should expect to get 140 hits. Now, the other way to do this is with a proportion, which is what they're showing us here in method number 2. In method number 2, they've used that same 4 out of 10 fraction. What does 4 out of 10 represent? Well, that represents here, if he goes to bat 10 times, 10 total bats, he's going to make a hit 4 times, which is where the fraction 4 out of 10 comes from. What they're saying here now is instead, let's bubble that total all the way up to 350. How many hits would he then get? Well, remember, when we set up a proportion, as we talked about when we did proportions in this book earlier this year, we have to be consistent with our setup. So writing the hits over the total on both sides is good, because that's the way we'd have to write that. So we look at this and say, okay, look at our denominators. How would I go from 10 to 350? Well, to go from 10 to 350, I'd be multiplying by 35. So I can do the exact same thing in the numerator. Remember, we can only multiply or divide, but I'm going to do the exact same thing in the numerator, and that's how I come up with 140. Now, they've even solved the proportion a little bit differently. They decided to go ahead and cross-multiply here. So what they did is they multiplied the diagonals. They did 10 times x, 10x, and they did 4 times 350, which is 1400, which is what you see right here, and then they solved the equation by dividing both sides by 10. Even though theirs is a little bit backwards because they've got the variable on the right, notice they still came up with the exact same solution we've come up with the 2 other ways we've talked about this. They still came up with 140. So no matter which method you do, he can expect to get 140 hits when he goes up to bat 350 times. All right, let's go ahead and take a look at the next example here. Example number 2 says a spinner has 8 sections of equal size. Now, of course, that equal size mention is important because yesterday, as you know, we talked about things being fair and equally likely. If they're not the same size, they're not equally likely, they're not fair, it's not in a section about probability proper. But since we are talking about the sections of equal size, it's all equally likely, it's fair, it's good to go. We can use it in a section about probability. The sections are labeled 3 sections are labeled 1, 2 are labeled 2, and the others are labeled 3, 4, and 5. In 50 spins, how often can you expect to spin a 1? So what we use here is what the question has said to us. There are 3 sections labeled 1, which is what we see at the end of that first line there. So we know the number of winning scenarios here is 3, and we're going to compare that to the total. Well, we've got 3 sections labeled 1, 2 labeled 2, and then we've got the others of 3, 4, and 5, so that's 1 each. So in total, we come up with 8 sections here on the spinner. So there's a 3 out of 8 chance of landing a 1. In other words, if I try this 8 times, I should land on the 1 3 out of those 8 times. Now the question says, at the end of line 2 and into line 3 there, what about if we try this 50 times? What if we make 50 spins? Well, let's go ahead and make 50 spins here. So what we're saying is we're going to have 3 times we're going to land on a 1 when we try it 8 total times. What if we try it 50 total times? Now, as you can see, what they've decided to do is they've decided to go ahead and write this as a proportion. So again, what we can do is we can cross multiply to solve, or if we see a number we can multiply by, we can use that and apply it to the other side of the fractions here. Well, unfortunately, with 8 and 50, most of us probably don't see what I'm going to multiply 8 by to get to 50. So cross multiplying is a better technique. So on the one diagonal, I've got 8 times x, which is what you see right here. On the other diagonal, I've got 3 times 50, which is what you see right here. So I've got 8x equals 150. Solve the equation. Well, we would divide both sides by 8. And when I divide both sides by 8, I end up with 18.75 for x. Now, obviously, we can't land on that 18.75 times, so you're going to round here accordingly, and you're going to say he's going to land on that probably about 19 times. If you wanted to solve this the other way, you could. You could say, okay, if I'm going to land on that 3 out of every 8 times, so I'm going to take 3 out of 8 and simply multiply it by 50, as in 50 for the 50 spins we're going to try. If I take 50 and multiply it by 3, I get 150, and 150 divided by 8 changes into 18.75, which was no surprise the answer we got when we did the question the other way. So either way, you come up with the same solution. Take your probability, multiply it by the number of trials, or solve the resulting proportion. All right, number 3. The Singh family is planning a 7-day tropical vacation during July or August. The island destination they have chosen averages 21 rainy days during this 62-day period. If the Singhs would like to avoid rain on at least 5 days of their vacation, should they go to this spot or choose another? So let's look at what we've got here. Important information. They're going to plan a 7-day vacation. The island averages 21 rainy days during the 62-day period, and they would like to avoid rain on at least 5 days of their vacation. Or another way to say that could come handy for us is they can have rain on 2 out of the 7 days of their vacation. So what are we going to do here? Well, since we know 21 of 62 days are raining, we're going to take that information and find out the number of rainy days there should be for 7 days, subtracting to find the number of non-rainy days. Again, we said that was important here. We were going to end up using that subtraction here to find out how many days it could rain. It could rain on 2 to give them 5 nice days. So, let's see what we got here. We got the fraction 21 over 62. What does 21 over 62 represent? Again, it represents the number of days it rains compared to the total number of days in July and August. So we've written it as rain over total. So for the other fraction, the total part is going to have to be 7 because it rains, or their vacation is 7 total days. The top is how many days, once we figure it out, it's going to rain on their vacation. Well, if we take a look at the fraction here, or the fractions, plural, 62 to 7, most of us don't know how I would go from 62 to 7 with multiplication, multiplying by a fraction, or really probably what we would think of is division. So cross multiplying is the ticket here. So we're going to multiply the diagonals, and we're going to say 62 times x, which is what you see right here, is the same as 21 times 7, which is what you see right here, 147. This is a multiplication equation, so you're going to solve that by dividing. When I divide both sides by 62, remember we're getting the variable by itself on the left side, and as you can see I flipped it around there to make it look like what you've become accustomed to in the last year. When I solve this out by dividing, I get x is approximately 2.4. So that means there's going to be about 2.4 rainy days on their 7-day vacation mathematically. So it's going to rain for 2 full days and then about half of another day. Well, remember, what the question says here is that it can only have 2 rainy days. Anything more than that, and they don't want to go there. So here, because of that here, it's not going to work. Even if we round up and we're really generous here, with, as you can see, that's why they're doing 7 minus 3 on the next line. Again, rounding that 2.4 way up to 3 there with the rounding. All right. They're saying 4 days are only going to be nice. They wanted 5 nice days, which is how you end up with 2 rainy days if you have 5 nice days. So based on that scenario, the Sing should choose somewhere else to vacation. It's likely to rain more than 2 days during the 7-day period, which will not give them the 5 sunny days that they've hoped for. All right, so let's look at the concluding questions here. Number 1, Marty finds the experimental probability of him making a field goal to be 74%. Out of 150 field goal attempts, how many times can he expect to make a field goal? So let's do this one the easy way. He's going to make 74% of his field goals. So 74% of being an operative word meaning multiply, of his field goals, and the number of field goals he's trying is 150. So I'm just going to take the 2 numbers I have in the question, 74% and 150, and multiply. Now you're probably going to change 74% into a decimal, move the decimal 2 times to the left and get rid of the percent sign, 0.74, and 0.74 times 150 is exactly what you see on the screen, 111. All right, number 2. Rhonda rolls a number cube 330 times. How many times can she expect to roll a 5? So, first thing we need to do is actually calculate the probability of getting a 5. Well, the probability of getting a 5, there's one thing that's a 5, so one possible winning scenario here, out of 6 total possibilities. 1, 2, 3, 4, 5, and 6. So there's a 1 out of 6 chance of me getting a 5 here. They want me to now, instead of rolling this just 6 total times and having one winning scenario, roll this 330 total times. So as you can see, we're setting this up to be solved with a proportion here. We said there's one winning scenario out of 6 total scenarios. What if we instead tried this 330 total times? Again, when we write our proportion, we have to worry about consistency. So since I've put total numbers on the bottom over here, it has to go on the bottom over here as well. The top, I don't know, that's what I'm solving, that's where my variable goes. Now, 6 to 330 is not something most of us probably know off the top of our heads. I will tell you it is actually an integer, it's not a decimal or a fraction. It is a whole number, but most of us just don't know that multiplier. So we're probably better off to cross multiply here. On the one diagonal, you've got 6 times x, 6x. And on the other diagonal, 1 times 330, which is 330. So 6 times what number is 330? Well, if we divide both sides by 6, which is how we would solve the equation properly, using the techniques you've used all year, you end up with x equaling 55. So if she rolls the number cube 330 times, 55 of those times she should expect to land on a 5. And you can check it. Take the fraction 55 over 330 and reduce it. And guess what? When you reduce the fraction 55 over 1/3 or 55 over 330, it reduces to 1 over 6. All right, let's try one more like our story problem here. It says the Berry family is planning a 12-day vacation to a beach. The beach they have chosen averages 45 rainy days during this 109-day period. If the Berries would like to avoid rain on at least 7 days of their vacation, should they go to this spot or choose another? So, if they're going to avoid rain on 7 days of their vacation, that means it can rain on 5 days of their vacation. And we'll keep that in mind when we solve here. So, what the question says here in line 2 is you have 45 rainy days during this time period, which is 109 total days. What they want me to do now is make that scenario match their vacation. Their vacation is going to be 12 total days. So I'm going to write my other fraction to be something over 12. Because again, it's total days, and where did I write my total numbers? My total numbers are in the denominator. I'm going to figure out how many rainy days that generates and see if it matches their situation or not. So, to go from 109 to 12, most of us don't have a clue. So we're better off to cross multiply here. So let's cross multiply to solve. 109 times x on this one diagonal is 109x, and 45 times 12 on this other diagonal is 540. Well, there's your multiplication equation. Of course, you're going to solve that by dividing across by 109. When I take 540 and divide by 109, the result is 4.95, approximately. There's some more numbers there, but that's good enough. Now remember, we figured out, since they said they wanted to avoid rain on 7 days, they could have 5 rainy days. Well, based on this calculation here, because remember the top represents how many rainy days they're going to have about 4.95 rainy days. So 4 days and then almost all of another day, but that's less than 5. So since they're only going to have about 4.95 rainy days here, based on our calculation, that means yes, they can go to this vacation spot. They will be able to enjoy their 7 nice days on their 12-day vacation.